New to DevOps?
Or simply not sure what are the best practices to implement DevOps on AWS?
Well, keep watching and we will bring you right up to speed. Hi, my name's Donnie.
And I'm Derek. In this video, we will provide you with a crash course on DevOps in practice.
We will learn all about the particular methodologies and tools that can help you build and operate your application on AWS. We will go through the terms that you need to know and how they relate to how you run these applications.
And we also have demos for all of you.
Lots of Donnie demos and Derek demos. So let's start by describing the 4 things you need to know when starting your DevOps journey on AWS.
So let's start off with Infrastructure as Code, or IaC. Infrastructure as Code is a really cool way to set up your infrastructure. And I honestly think that this is the only way, Derek. Right? And with Infrastructure as Code, you can build and code your infrastructure with your code. Now, the basic idea is to use code and software tools to set up and manage your servers, databases, networks, and all, instead of doing it all manually. So it's like you write scripts that build your infrastructure for you automatically. Pretty neat, right?
That's pretty neat. That sounds great. But why do we need it, Donnie?
Okay, so that's a really good question.
Oh, thank you.
Well, you can find all benefits of implementing IaC on the internet. But for me, there are 3 main benefits on implementing infrastructure as code. The first one, that you will have a consistent deployment.
Yep.
Right? And the second one, that with IaC, you can deploy to any environments, either at staging, UAT, or productions.
Yep.
Now, the second benefit is that you will have a predictable deployment. So there will be no questions that, wait, what is the IAM permissions again?
Right? I don't know.
Yeah, so that's something that you can get benefits from IaC. And the last benefits for you is that it provides opportunity for collaboration with your team. Now, you probably have heard about AWS Cloud Development Kit, or widely known as CDK. And also there's another tool called HashiCorp Terraform, Ansible, and many more. You might have a question, which tools I need to use? Now, before we go there, so let's define the categories. So in general, there are 2 flavors that you can choose on IaC tools. It's either declarative and imperative. So declarative is where you describe the end state that you want. Imperative is where you write step-by-step commands to provision things for your infrastructure. So if you need to choose the tools, my advice is that think about how that you want to do it. You want to describe the state, or you want to write the step-by-step commands. Workflow comes first before tools. After IaC, we have continuous configurations, sometimes called as config as code. Now, Derek, can you please elaborate more about this?
Love to, Mas Donnie. So, continuous configuration is all about abstracting the application's configuration away from its code. Like infrastructure as code, there are also 2 main types that you can call static and dynamic. So static is configuration that never changes once the application is deployed. So it's usually configuration tied to a particular environment, like dev or prod. Dynamic, on the other hand, can change once the application is deployed. This can also be called feature flags or feature toggles, where configuration is used to enable or disable particular features in a running application. So like infrastructure, config as code is also a major part of an automated CI/CD pipeline. And we use tools like AWS App Config to manage it. But we haven't talked about CI/CD yet. Mas Donnie, you want to do that next?
I would love to. So the fundamental idea of CI/CD is really simple: to ship applications from your local to your servers or cloud. Now, within CI/CD, there are 3 concepts: continuous integration, continuous delivery, and continuous deployment. CI stands for continuous integration. It's all about taking codes that you have, that you've been working on, and automatically build, test, and merging it into repositories frequently. The goal is to catch issues early before they become big problems. Right. Now, CD stands for continuous delivery and continuous deployment. This approach is to take the code that you have and pass the test in continuous integration and automatically pushing it to your environments. CI/CD in general consists of 4 stages: source, and then build, test, and deploy stages. So in source control, wherever you commit your code, it will trigger the pipeline. Then on the next stage, called build stage, it will automatically process your source code and compiles links and packages as a build artifacts. The next stage is called test. In this stage, it will going to run automated tests to validate the build. The objective is to catch issues early. And lastly, deploy stage. It releases the build and tested code to production environments. And similar to IaC, there are many tools that you can use to implement CI/CD, such as Jenkins, Circle CI, Travis, to AWS Code Build, and AWS Code Pipeline. In a nutshell, CI/CD is a huge thing for modern development workflows. It catches issues fast and accelerates delivery of your features to your users. Right, so in this demo, we're going to show you on how that you can build IaC and CI/CD with AWS CDK. So let's assume that we are building serverless REST APIs with AWS Lambda. And this is the AWS CDK applications. So as you can see, it's written in Python. And the way it works is that you just need to use the libraries that we already provided within AWS CDK. Right, so you can see we have AWS CDK, we're importing library from IAM, Lambda, DynamoDB. And if we go down to the end of the source code, you can see that we have this stack and application. Now, this is something that you define for your applications. Now, let's see what we have for the stack. Now, this stack is actually a composed source code for your applications. The first one that we define here is the DynamoDB table. As you can see, a lot of properties that we have defined here, similar to what you have on your Amazon DynamoDB console. Next one, we can also define the IAM roles. In this case, I'm providing IAM roles for AWS Lambda. And I can define a granular level of this IAM role. In this case, I'm using DynamoDB IAM roles and also CloudWatch. Now, this means that you can implement your least privilege approach with AWS CDK. And here is the AWS Lambda function definition. And you can see on the left side, this is actually the source code of my application. Now, so moving on to the next one, we also have a couple of AWS Lambda. And one of the really good thing about AWS CDK is that you can use the L3 constructs, which means that you don't need to start from scratch. In this case, we are building a REST API, and then we integrate with AWS Lambda. And we can also define the URI and method. Here I'm using post, get, and also delete. And lastly, I'm just going to output the results. Now let's try to deploy this application. So the way that you can do manually if you want to deploy your applications using CDK CLI is running CDK deploy. And there you go. You can see that we have all the URLs. Next one, we're going to show you on how that you can set up CI/CD, still with AWS CDK. The first thing that we need to do is that we need to put the Git repo connections in AWS Developer Tools. As you can see, I already have the GitHub connections already established. And then the next thing that I usually do is that I just copy and paste the ARN and then put it into the AWS SSM parameter store. Now, I want to show you how it looks like when you use CDK pipelines to build CI/CD for your CDK application. So here is the modified source code, and you can see that I've already included SSM library, and there's another library, it's called Pipelines library from AWS CDK, and here you go. Now, moving on, I want to show you how it's going to be to define the pipelines with AWS CDK pipelines. And this is the same stack that I showed you in the previous demo, which is the serverless API. And here you can define the account ID and also the AWS regions, which also means that you can use CDK pipelines to deploy to multiple accounts of AWS for your environments. So you just need to pass these environments to the CDK pipeline. As you can see here, this is the pipeline stack. Now, the next thing that we need to review is that how did we define this pipeline stack to define all those stages that we already shared with you. So we're going to skip to the pipeline stack. Right, so the first thing that I usually do in the pipeline stack is to define the Git connections. It could be GitHub, it could be some other Git repository that will be supported by AWS Code Pipeline. Here in this case, I'm using SSM parameter store, and then I define the steps. Here I'm using the shell step. I'm also define the Git repo. Here I'm using Donnie /demo-cdk, and I pass the connection ARN. And I also included some comments that I need to build my applications. And this also means that you can also integrate with the testing tools that you have. And then the next one is this: I just need to define the staging environment. And then this is the way we define it, and then we add the stage into the pipeline. Right, so let's see how it looks like once that we deploy in Code Pipeline. So here's what it looks like when you successfully deploy your CDK applications with CDK pipelines. We have source, we have, and then this is where we're going to gather all your codes. We have build, we have update pipelines, and it's going to deploy your applications into your environment. So if you see here, we can also get the outputs of the URL similar to what we had when we deploy manually with the CDK. And if you run this URL, and your application is running in multiple environments.
Nice. Finally, we have observability, or OLI. Observability is all about understanding your application and how it runs. This is usually done using 3 key aspects, which are metrics, logs, and tracing, which I call MELT. In AWS terms, we use Amazon CloudWatch for logs and metrics, and Amazon X-Ray for traces. We also see customers using OpenTelemetry, or OTel, which is an open standard on collecting MELT, and as such, has great community backing. When we've implemented a nice observability strategy for your application, you can quickly identify issues that occur in your application. This then leads to an enhanced user experience and delight for your application, which can only be good. So let's jump into a quick demo on one of these aspects of OLI, tracing. Here I have a Lambda function. It's getting called by API Gateway and storing information inside a database. It's written in Python, so you can see some Python code here. And what I'm doing, I'm using AWS Cloud Shell to exercise this application. So it's throwing lots of requests at the application, and you can see it's getting back an internal server error. So a new feature of the Lambda console is inside monitoring. We can actually see all of the MELT features, so metrics, logs, and traces, all in one place, which is very handy. So we can scroll past the metrics. We'll see logs, so in metrics we can see error counts and throttles and stuff like that. And then below that we can see the logs. But for this demo we're going to concentrate more on traces. And this is the traces for the application. You can see they're all errored, as we'd expect, and you can see where the error occurs. So we've got an error that's happening in this application, and AWS X-Ray is telling us where that has happened. So we can dig into these and see exactly what's happened. So if we dig into the overview, we can see the ID, when it happened, and we also have a tab that tells us the exception. So if we dig into that, we can see the message from the exception was, oops, something is not working. So this gives us a good insight into the function. So if we go back into this function again, have a look at the code, we can see that, well, someone has raised an exception in the code. So by simply removing that, redeploying the application, and then exercising it again, you can see that it's now successful. So X-Ray has helped us fix this application using observability. And there we see the application, the traces are now all okay. So if we jump into a trace, you'll notice that as this application is actually updating a database, what's missing is the trace into the DynamoDB database. So if we start putting some data into the application via another curl command, we would expect to see a trace that included the database. So To get that, we're actually going to use Lambda Power Tools. So Lambda Power Tools is an open source library that you can add to your Lambda function, and it adds best practice for metrics, logs, and tracing. Here I have it imported as a layer, so it can be reused across multiple Lambda functions, and I simply import the parts of the library that I'm going to use. For this demo, I'm going to use the tracer. Once I've imported it, I then use it as an aspect on top of the handler to tell the X-ray trace that I want a trace to be captured here, and I can also put metadata into the trace inside each method as it's called. So this will give me better granular information about the Lambda trace. Let's then put some more data into the application, so exercise it again and see what our trace looks like after using Lambda Power Tools. So we're back into the console, back into the service map, and you can see here we now have a database. So if we click into one of the traces, we should be able to see the trace propagate through Lambda and API Gateway and into the database. And also, because we put traces inside the code itself, we get granular information about the Lambda function as it is invoked. And here we have the actual data it was invoked with as well. So extra information giving us a great insight into what's happening inside our Lambda. As well as that, once we use Power Tools, we can see what operation was being used on our data, Amazon DynamoDB as well. So again, more information to help you understand what your application is doing as it's exercised, all using Lambda Power Tools and the power of Ollie. So today, we have summarized what DevOps is when it comes to AWS. Donnie, do you want to go through each of the aspects again?
Sure thing. So 4 things that you need to remember. First one, infrastructure as code, or IaC, is treating your infrastructure like code. So you can have version control, testing, and all to help you to have more predictable and consistent deployments. Continuous configuration is like IaC and the CI/CD for your configs. So config files are important. They define how your applications behave. And you definitely need to implement this to keep your applications run as expected. And CI/CD pipelines is how to ship your applications from your locals to servers or cloud. It's done automatically for building, testing, and deployment of code for changes. Done right, it will improve the stability of your applications. And lastly is the observability, or OLI, and monitoring. Now, this is how that you know what's happening under the hood of your applications. It provides deep visibility into applications and systems. Not just dashboards, but insights into usage and errors. Some say monitoring is enough, but observability is definitely a game changer. Now, things to note, all of this DevOps stuff that we share, they take work to implement, but they do pay dividends for you in the long run.
So, if you'd like to learn more about DevOps and some of the services we have covered today, check out the links in the description. And if you liked the video and want more hands-on technical content, be sure to like this video and subscribe to the AWS Developers YouTube channel.